B is congruent to angle R, and segment or side, I guess we could say side GI is congruent to side RT. Therefore, it is possible to prove congruence using AAS. Once the triangles are proven congruent, then it is possible through CP-CTC. Now, have you seen that in class, CP-CTC?
Yeah.
Okay, so that means corresponding parts of congruent triangles are congruent. Most students use CP-CTC as a shorthand. What that allows you to do is prove, or not prove, but show that the sides are congruent, and therefore it would then be possible to use SSS to prove congruence. However, the triangles have already been proven congruent. So that's kind of a, I think that's too much, but so I get, okay, the other thing here is we got to be careful. I'm probably not answering the question exactly. So we want to be more specific. We want to say that two angles and a side are given as congruent, and no other information is available to show that any of the other sides are congruent. Like we probably do need to address the point that it is not sufficient.
Yeah, we don't have enough information.
Yeah, and maybe say no, there is not. Maybe we want to. This is a good thing to take away, is that you always want to reuse their words. There is not sufficient information. Okay, you kind of want to use their words, because one, it shows that you read the question. And another second thing is that, you know, if they wrote them, they probably think they're important. So often that's a good way to demonstrate understanding. This is way too much, but I mean, we've learned your teacher wants max effort here. So till that changes, you know, until they say, hey, you're giving me too much, I guess let's give them more and more and more.
All right. Let's look it over. All right. So the next one I have over here is number 4.
Okay.
Let me put it in the chat.
Any questions on this one though, before we move on? I mean, don't let it by here if it's not clear.
So we're proving AAS, that it's congruent by AAS because there's angle side. Yeah, right. There's two
And
angles there that are congruent on the side.
and the order matters. The side has to follow the second angle, like it's a path.
Got it.
And what I think is implied here is you can't just be like, oh, well, since AAS works, then all sides must be congruent. So SSS works. And I think that's implied here, but it's not stated explicitly.
All right. So I'm gonna put the next one in here. Here it is. Number 4.
Okay. Let me know when that's in the chat. There it is. All right. All right, let's click all the buttons here. All right, so new picture. Nice picture here. Let's see what we got here. All right, it says RSTU is a parallelogram. So that's important. The parallelogram opens up a ton of things, first of all. So when you have a parallelogram, you know a bunch of things right away. You know that opposite sides are congruent. You know that opposite sides are parallel.
Yep.
Then that opens up things with angles. It means that that angle equals that angle, the other angle equals the other angle. Lots of stuff opens up, okay? Now, let's see what they're giving us next. Measure of angle TSV, T to S to V, that's 31 degrees, okay? And measure of SVT is 126 degrees. Explain how you can find the measure of URV. Okay. So we're interested in finding this angle down here. That seem right to you?
Oh, yes, is yeah, they're saying those two are the URV, yeah, it appears to be that, yeah, URV, so basically the angle, yeah.
Is that okay? Just making sure. Just I don't want to.
Yeah, that kind of makes sense, yeah.
I can talk to myself without someone being on Zoom. So it's always good to know that your understanding is there. All right. So one of the things that they do in geometry is they add extra lines, and I don't know, it's confusing. It's like, why are there all these extra lines? Um, this first diagonal here is really between two parallel lines. It's a transversal. So
Yeah, between the two
this
parallel lines, yeah,
right.
and then the other side would also
That's
be
right. So what do we know about this angle? Oh, we change colors here. What do we know about the angles in red?
that's alternate interior.
And they're congruent. Now, in terms of your triangle, that means that one's 31 degrees. Does that
Yep,
make sense?
yeah. And
Okay, so
then
that's go ahead.
yeah,
You see something else?
so then using that 31 degrees, so they're trying to find URV. I feel like there's a term for that, but I don't remember. But oh yeah, wouldn't you use I think it's
So let's look at one.
CPCTC to prove that uh angle R or angle URV is also 31 degrees?
You can prove congruence if you
Oh
need
wait,
to.
but it's different. Yeah, never mind. That probably wouldn't work.
So because this one has specific angle measures, we're kind of looking more at not necessarily congruence, but what do you think that up to, or which ones are the same in the triangle? So one other thing here is if you look at the two diagonals, if this is 126 degrees, what is the angle right down here?
126 because it's a vertical.
126 is a vertical angle. So far you've said alternate interior angles, vertical angles. All right, now to find this missing angle here, I assume somewhere
Oh
you guys have talked about the sum of the interior angles of a
yeah,
triangle
yeah,
being
yeah. Because
180.
it's supposed to be 180, and then
Okay,
yeah,
so that's sufficient. Now, that's just one way to do it. You could also, for example, find this other angle up here where my cursor is. We'll show that in green through the same thing. And then by alternate interior angles, prove that it's the same as this one.
yeah.
There's a number of options here. So I mean, did something stand out to you? Do you want to try writing this down and then like sending over what you've written down, and I can kind of help you make changes to it?
All right.
I think that would be a good exercise for you to just, even if you just drop it in the chat, you just type a few sentences about why or what you're going to say, and I'll kind of help you massage it. But
All right,
why don't you give it a first shot here?
let me open up here. Okay. All right, so. Oh yeah, I wanted to ask one thing. Is the triangle sum theorem and the angle sum property the same thing?
No, the triangle sum theorem means that the three angles add up to 180 degrees.
Got it. All right. So this is I
All
put it
right,
in the chat.
got it here. So there's a few things that I'm looking for, like as a grader, depending on the direction you're going. But let's take a look here. So using angle TSV, which given 31 degrees, know that angle RUV is also 31 degrees because they're alternate interior angles. Okay, you might want to add that. You might want to start out by saying, since and you know, RSTU is a parallelogram. That means that ST and RU are parallel. That's the whole challenge of geometry, is like you have to say the obvious. Okay. All right.
Got it.
And furthermore, and then you have to add in that SU is a transversal and diagonal SU is a transversal.
Got it.
Okay. Now you can say what you're about to say, which is that they're alternate triangles. Um, and you almost need to add in there and alternate interior angles are congruent. It's like, why do I have to say that? It's like, well, it's not enough to just say that they're alternate interior angles. You have to say that they are congruent.
Got it.
Vertical angles. So then same thing for the vertical angles. Yes, they're vertical angles, but you have to add in here because vertical angles are congruent. All three angles of triangles have 90 degrees. All right, so that the rest of it is
Yeah,
more than
that's just
accessible.
explaining that using the triangle sum, that
Yeah,
triangle sum theorem means that all three angles add up to
right.
180. So then we're just like adding 126 plus the 31 and subtracting it from 180, getting us the 23 degrees that's which is the measure of angle URV. All right, so here. All right. So yeah. Now we're done with that. One second. Let me just grab it. There's no more thing I would like to go over. There's none left, so to go over one more thing. So today I did start module 3,
Yes.
and I did the pretest for it. There was, or actually not the sorry, not the pretest. The one thing I wanted to go over was actually this part in the module part 1
Okay,
Um,
sounds good.
let's see if I can, should be able to, yeah, there we go. There was this one question that I got it right, but most importantly, I didn't really understand the question to begin with, and then I got it right, but I didn't really understand why. So,
Yeah, always good to get the the why.
so let me pop that into the chat. Because me and Dad were looking at this before I submitted it, and we both were kind of confused on. It looks like two of the answers are correct, but there's obviously only going to be one answer that's correct, and I didn't be the one that I ended up choosing. But uh, yeah, you go see. Once you do open it up, you'll see the first one and the third one both
Okay.
kind of look to be the right answer.
All right. So the yeah, this I was kind of alluding to this earlier. When you draw, it's important to actually draw these two triangles, and we're going to label them in the same order: A, B, C, D, E, F. Okay. Now it's clear when you're drawing it like this, but then the order matters. Like if you're going from A to B is congruent to D to E. But you're going in that direction.
So
So
the
similar,
direction like that
yeah.
kind
So
of
similarly,
matters.
similarly, if you say BA is congruent to ED, that is also correct. Now you might wonder, well, where does that come from? It comes from the order of the letters. So see how A and B are next to each other? A goes to B, B goes to E. B
Got it.
similarly goes to C, and E goes to F.
Got it. So the
So
one
that
yeah, sorry to interrupt, but
what
the one that we're kind of contemplating before submitting this was C, A, and D, F, because those two are, because
but the
those
order
are the
they're it's
base.
in the wrong order. C goes, see how C wraps around to A in triangle ABC?
Yeah.
C
So
wraps
then it
around to
should be
A.
should be FD,
That's right.
because
It would have to be F to D in that case. The order matters. The direction matters.
got it. Yeah, that makes yeah, yeah, I think now I kind of get like that kind of sort of not really a rule, but like how to do it. Because
Yeah.
the direction's always like the next letter that's right next to it. So if it's like triangle ABC, then you can't really say that BA in the series 9 that is congruent. Well, one, because it's not correct, and two, because it wouldn't be the correct order. So it has to be in the order of the given. Oh, got it. And then if it's the last one, then you have to, all right, yeah, got it. Yeah,
Same
I
thing
think,
applies to the angles, especially if you're using 3 letters for the angles. They're only using one. But if you were to go BAC, that's the same as EDF. BAC, EDF. You have
and
to choose the same
s-
order, same direction, same path.
so if it was like BCA, it would have to be EFD.
Exactly. Yeah.
Got it. Yeah, that makes a lot more sense. Uh, all right. Um, so now there is one thing I like to go over in module 3,
Okay.
and this was the pretest. Um, kind of, so here, let me just
Do
quickly
you get a
find.
pretest for every module?
Yeah, and it's like it doesn't count towards our grade. It's kind of like just see where we are. So let's see. This was one that I didn't quite understand. So let me put this in the chat. Here, let me wait for it to pop up here. All right, it's in the chat.
All right, there we go. All right, which of the following best completes the proof showing that triangle WXZ XZ is similar to triangle XYZ? Okay. A little bit of background here is there's actually 3 triangles. There's the small triangle, there's the medium triangle, and then there's the large triangle. Hopefully you see that when you look at this. That's kind of an aside here, but
Got it.
um, now there's the way to do this problem. I actually need to reframe it here. Is to this takes a little bit of extra work, but there are in each triangle, there's a small triangle, a medium triangle, and a large triangle. And there is a short leg, a long leg, and a hypotenuse.
Mhm.
And it's to figure out, and you won't do this all every time, but I'm going to do it for one problem here. It's to figure out, well, what exactly are you given? And for example here, this three is the short leg of the small triangle. Okay.
Got
The
it.
6 is the long leg of the short triangle. But this 6 is also the short leg of the medium triangle. And the long leg of the medium triangle is 12. All right. Now, what else do we have? We actually know that the hypotenuse of the large triangle is 15. It's kind of an aside. But in terms of like the proportion, it comes from this table. Okay. Now, what you normally do is you kind of look ahead to see what you have and you build a proportion based on that. But you can see here that 3/6 equals 6/12, and that one corresponds to this one here. And so when you set up these proportions, you pick two of the triangles, two of the three, and then two of the three sides to put into proportion. And hopefully you have three of the four values, or if you only have two of the four, the other two must be the same.
Got it. Yeah, that makes a little bit more sense because this one I was like, I didn't understand a whole lot of it, because yeah, this didn't understand how to really do it, but not like now I kind of understand. I kind of just trying to understand it. Of course, I'll probably go over it a little bit later, like in the
Yeah, if it's a
later.
pretest, I mean, you'll see some more numerical examples of this.
Yeah. Anyways, so here. But I did notice in this pretest, a lot of the stuff that I got wrong is related to like dilations. So
Okay.
there, here, let me see. Just hold on. And like the center of dilation, for example, here, like put this on the chat, this question from here. Put it in the chat right here. Right, I think it's in the chat now. So
All
number
right, there it
two,
is.
the pretest.
All right, it says AB was dilated by a scale factor to create A prime at B prime. What point is the center of dilation? Okay. How do we want to say this here? So typically, and this is why, so typically the dilations are centered at the origin, and you just enhance the image based on that. The short of it is that it's the one that lines that these all line up with. Um, Plus you can see that there's this triangle now that's created. There's now two similar triangles that are created as a result of that.
Yeah,
So it really comes down to adding some extra lines. Um,
got it.
the more common question you'll see is actually, what is the new
Yeah,
image
because
after the
I thought it
dilation?
was, yeah, 'cause I thought it was L first, but
So the
Yeah,
problem with L, I guess, is if we're to try to sort of like connect these things, you wouldn't have enough to prove uh
but yeah, M is the only
congruence.
one that's like on the line with the other 2 points.
So for similarity, sorry, not congruence, it's angle, 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 or side, angle, side. And with the way I've drawn it here, I'm gonna maybe overlap it. You get the side angle side here because they share an angle, whereas the one in reds, they don't share anything.
Got it. Like with the M, you kind of share like that one line that can go through all of them.
Yeah, you get the double angle there, and then
Yeah,
the sides are the
yeah,
same.
that kind of makes sense. And then you draw out the second line, and then it kind of
Yeah.
lines up with.
A- Angle, angle, angle is generally some sort of an overlap. Or I'm sorry, one inscribed inside the other.
Got it. All right. See. Me- So this is another question. Yeah, I was kind of questioning how to do. Um, yeah, it should be in the chat now.
There it is. Right. So let's take a look here. Why didn't it paste? There it is. Okay. Are the triangles similar? You have to find the third angle first. So when you find the third angle, it's 65 degrees there and 62 degrees there.
God.
Okay, so that like there's kind of always that first initial push. So because all the angles are the same, you can say by angle, 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 they are similar. It's not asking for that, but they are similar. Now you do have to match them up. So like the 65, which is the B, goes with the D. Okay. But now you gotta be careful. You gotta decide, well, which way am I going? Am I going to the A? And actually, I'm sorry, let's back up here. This is not the right way to do this. Let's start at A. A goes with A and F go together. Now, from
Got it.
A, if we go to B, that means from F, we have to go to the 65-degree angle, which is D. It's not a choice. You have to follow the direction. Like if you start at the 53 and you're going to 65, then you're going to the 65. And then you get the C, and then it must be the other angle, E, like that. So that, I mean, that really helps. I mean, that eliminates everything but this one. Now, this proportionality thing over here, I don't really
Yeah,
like the way
that's
it's
that.
written.
Yeah, that kind of confused me a bit because I was wondering
So
what
so
that
now that we
meant.
know that A is congruent to F, okay. So where is X? X is across from A. So X over X corresponds to which side over here? Well, it's the one across from the 53, which is the Z. And then W is from A to B. So we want the one that's from F to D. So I'm like, because it's A to B, I'm wanting the one from F to D. F to D is the R, like that. So that's just a proportionality thing that you're setting up, and then they're just solving it for X. There's not really anything useful, but they're solving it for x. So they multiply both sides by z. And that produces x equals z times w over r, like that.
Got it. And of course, we'll probably get more into this as the lesson that we got through module 3 this week.
Yeah.
Or next week, maybe. But here, like, all right. This one's pretty key one I wanted to go over because, yeah, this one, yeah, we've gone over a little bit of this. Let me put this in the chat. Okay, let me put it in the chat here.
All right, there it is. Oh boy, here's a biggie. A lot going on here. All right, all right, in triangle ABC, DE is parallel to AC. Notice that they share an angle. So we're going to be able to show that they are, this little one is proportional or similar to the big one. But it's a side angle side, I think, again, because they share the angle. You kind of got that side, those sides going down. Okay. Sorry about that. It's not supposed to be on right now. All right. Joe, we're trying to complete the proof. So it says that DE is parallel to AC, that's given. AB is a transversal that intersects two parallel lines. So that one allows you to show that this angle is congruent to this angle, and then the angles over here are congruent as well. Does that make sense? Like the thing that follows 3 has to be whatever 2 tells you. I know it's easier because I've done this a million times, but what you have to do as a student is look at the statement and be like, well, what follows? Like, okay, they're parallel. Well, that means some angles are congruent, the corresponding angles. So that gets you down to either, the first 2, because the first 2 are corresponding. Then
Then,
go ahead.
yeah, here it is. If you look down there, I think the two different, here, one second, let me pull up the question here. Okay, close it out. Okay, here, then after that, oh, yeah, I see the difference. Yes, I see the difference.
Okay. So
And
then,
that's,
okay, so here's what you've got. You've got that this angle and this angle are congruent, this angle and this angle are congruent. I tell students all the time, draw separate triangles. Like you can't visually break this apart. It's just way too hard. Okay. And it's not a good skill to have either. I mean, you can try, but it's better to just take 10 seconds. Then, so like, what are we trying to prove? Well, proportionality. Well, now we have that angle B is congruent to itself. So that third angle is congruent. You're sort of building the proof in pictures as you go down here. Well, what does that mean? Well, it means that the triangles are proportional. So we're choosing between A and B. Well, they both say the same thing, but the A is the only one. See how this has a triangle here? Triangles, and this one has angles.
yeah,
That's bad. I mean, if you're proving triangles are proportional, well, You'd better be triangles, not angles.
Yeah, so that kind
So,
of finals it
yeah,
down, but
yeah,
to like the one that's correct. So
yes,
it's kind of all about kind of like looking at the proof that's hard, parts of the proof that's already there,
yes.
and kind of trying to kind of looking at the steps before it to kind of fill in the blank. All right. All right, so yeah, this question it did end up getting me. There we go. Should be in the chat now.
There it is. Print that real quick. Another big one here. Let's see if we can piece this together. All right, C is the circumcenter of an isosceles triangle. ABD with vertex angle ABD. C is the circumcenter. Okay, circumcenter of that. All right. Congruent. ABE and DBE. Okay, congruent. All right. There's an error in line 2. Segment BE should not, could be. B should be a perpendicular bisector. Okay. So given that C is a circumcenter triangle ABD, making segment BE a median. Yeah, so you have to, you would need to go and actually know what a circumcenter is.
Yeah, I think we went over that. I think I got that in my notes actually. The circumcenter. Let me pull it up. Wait.
So I mean, by definition, it's the perpendiculars. All the perpendiculars meet there. So if you can imagine this being a really accurate drawing, that's 90 degrees. And then
Yeah,
this
yes,
one is
also
also 90 degrees. And then this one is also,
it's the center of all the perpendicular bisectors.
right. And that's why, I mean, it's one word difference. It's median versus perpendicular bisector there.
Uh, got it.
All right, so we're going to go ahead and stop here for today.